home stretch of ACT. And so it's less about lessons or this is the stuff that we still need to know, and more about just getting the practice, getting comfortable with the problems, and getting exposed to what the problems are like. When I started to teach this class, I sat down with the book and did like 10 ACT tests. It was a lot. I did not do it in one session. I don't recommend that you do it in one session. But at the same time, it just gives you the exposure of, oh, this is how they ask these questions. Or this is the way that they're expecting you to answer. Or, hey, I have seen this an awful lot. And so the more comfortable you get with the test, the more you can just focus on answering rather than trying to figure out what's going on and answering. It's the difference between finding your way to a restaurant if you go to St. Louis versus finding your way to a restaurant if you go to Mexico. Either way, you're trying to figure out how to get to a place, but in one place, you already know the language. And so it's about removing that extra barrier of being unfamiliar with the format and needing to know the question versus, yeah, I know what's going on, I can just give my answer. And so that's what we're aiming for. We are going to go to practice test 8 in our book, but before we get into that, do you have any questions from the homework? It's always open to ask them, and honestly, if you have a question, somebody else is wishing that you'd ask it. So don't worry about the pressure, but if you do not have any individual questions, we're going to go ahead and dive to practice test 8. And again, getting used to that format, it's on page 614 is where we're going to start, because frequently the first 10 questions are kind of warm-up questions. They're going to be pretty easy, and then the last 10 questions tend to be not impossible, but taking longer than a minute apiece. And so if you think about the test is 60 questions in 60 minutes. That means if you answered one question per minute, you're done. But what happens is those first questions should take less than a minute. They should take 30 seconds or less. And your idea is to build up a time buffer, and then you have that extra time when you need it as you get to more difficult questions. For our lesson today, we're concentrating on the middle. So we're going to start at question 9 and then work forward. And what I'm going to do is give you 5 minutes to work on the test. And ideally, you should be 5 questions ahead or more. We're going to check those questions, we're going to talk about those questions, and then we'll do the next round. So you're always welcome to move ahead, but if I say, okay, it's been 5 minutes and we talk about questions 9, 10, 11, 12, and 13, just jump ahead and start with question 14 when we restart the timer. Don't feel like, oh, I'm behind, because then you've got, again, that reset, 5 minutes, 5 questions, see how much you can answer. It helps you understand the pacing, it helps you know what you know, and that's what we go for. All right. You may begin. Again, we're starting at question 9. Answer as many as you can, but try to get at least 5. time. How many of you got through the 5? Okay, that's good. This one is an interesting section. I picked the test at random, but these 5 questions, I would count 2 of these as conceptual. Do you have a question? Okay, so 2 of these are conceptual, and so they're either really easy, really fast, or they take some more time to calculate out if you don't know the trick behind it. So on number 9, this is actually one of the ones that's going to take longer because they tell us that the midpoint, but we're trying to find the end coordinates. And so we have point B is the midpoint. So again, it's give yourself a quick sketch. Here's A and C and B in the middle. And A is at the point 6, 7. Quickly, my drawing is going to be not to proper dimension, but that's okay. And B is the midpoint 5, 6. So, 2 ways to do this. You could go very formula heavy, the idea that 6 plus x divided by 2 equals 5, the midpoint coordinate, and 7 plus y divided by 2 equals 6, the y coordinate. You can also go with the concept. B is the middle. 6 and 5, how far apart are they? And so this is going to be 1 in the other direction. 6, 5, 4. 6 and 7, again, they're 1 apart. 1 more in the other direction. 7, 6, 5. 4, 5 is our midpoint. So you could solve it, or you can go conceptual. Both are okay ways to get that answer. Next up, we have a rectangle lies in the standard coordinate plane so that its sides are not parallel to the axes. In other words, it's sitting diagonal in the coordinate plane. What is the product of the slopes of all 4 sides? Did anybody know this one? Okay. This is getting into the fundamental idea of a rectangle. If we have a rectangle sitting in the coordinate plane, these are right angles, or perpendicular. In the coordinate plane, in order for these 2 sides to be perpendicular, there is a special property about the slopes. If this slope is up A over B, as in this distance up A over B for our slope, the perpendicular is the negative reciprocal. Which is the fancy math term for the opposite sign and flip the fraction. And so if this is up A over B, this is going to be B over A negative. It could be 3 and 4, it could be 5 and 2, it could be any numbers, but if they are perpendicular, they are this flipped fraction of themselves. And if we multiply these 2 together, what happens? It cancels out. This turns, we get negative 1. Now, again, back to the idea of a rectangle, these sides are going to be parallel. And so this is the same thing. This is A over B, and this is negative B over A. And again, these 2 together are going to equal negative 1. I keep hitting that, sorry. And these 2 multiplied together, negative 1 times negative 1 equals 1. So, a lot of you said that you didn't know what to do with that one. How many of you remembered to guess? Do not leave it blank. There are no points for leaving a question blank. There are no points taken from you for taking a guess. There's no penalty. You should always guess something, even if you do not have a clue. You're welcome to circle it as big as you need to in your book, saying, if I've got time, I'd like to come back and give this one another crack. But definitely fill in a bubble or mark it however you are taking this test. If you're doing it electronically, there's a flag option, but don't leave a question blank. There's absolutely no reason to not give a guess. So, got to learn about perpendicular. That one's a good one to come up. All right, looking at 11, we have Tom. He's traveling 45 miles in 12 hours. And we have Jim. Jim is traveling 4 times as far. What's 4 times as far? 180? And he's traveling that in 1/3 the time. What's 1/3 the time? 4. And so if we want what is his average speed in miles per hour, we're taking 180 divided by 4. Was it 45? Yeah, it's 45. Okay. So, remember, if they tell you miles per hour, per is division. It's telling you to divide the miles by the hours. So anytime there is a rate with that per in it, they're literally telling you how to set up the problem, and that can be a good hint for you. All right. 12. This is the second conceptual one. Like I said, if you understood perpendicular, that one's really fast. If you don't understand perpendicular, it's a bit of a doozy. This one is a little bit more approachable, even if you don't understand. So if we straight solve this triangle, we were looking for the sum of B and A and C, where we knew 43 and 81. So, if you're solving this straight, you're going to be finding out the value of A, you're going to be finding out the value of B, and you're going to find this angle so that you can find the value of C. Did you guys do that, or did you go conceptual? Okay, so that is a perfectly fine way to solve. 2 concepts to definitely be aware of. I just finished talking to the advanced about it. It doesn't go away. Linear pairs, line pairs adding up to 180, triangles adding up to 180. Both of those are very fundamentally good, and they would have helped you solve this. But for any shape, not just a triangle, any shape, I'm going to draw a pentagon. If they give you this setup where you have the exterior angles like this, I'm going to call this M, N, P, Q, and R. I have no idea what the measures of those angles are, but I can tell you what they add up all together. Because it's all the way around, it adds up to 360. An entire circle. This triangle, C, A, and B, it's all the way around, it adds up to 360. Any shape with those exterior angles is going to equal a complete circle, or 360. And so again, you could solve it, but if you're trying to build up that time so that you have time to attack those end of the test questions, this is one of those places that you pick up time to have it worked later. Again, I am of the opinion that all scores are good as long as you are doing your best and not freezing. But if you are aiming for the 36 or those even high 30 answers, it's going to be about picking up as much time as you can. But again, if you had solved it straight and got it right, a right answer is a right answer. So both are valid ways, but if you're in the hurry, that conceptual part is good. Again, on 13, finding the percentage is pretty straightforward. It's the number of things that meet the condition divided by total. So they ask about what percentage of students chose Spartans in the poll. Well, what number of students chose Spartans in the poll?
200?
Chose Spartans.
30.
30. And you are correct that there are 200. Again, you could find that 200 by adding up all of the students, but a little bit of a shortcut, they told you there were 200 in that introductory paragraph. And so we know we're dividing by 200, which works out to 15 out of 100 or 15%. All right. Let's take another round. So starting with question 14, 5 more minutes, 5 more questions. and how many people got to at least the 5 questions? All right. So, again, there will come a time later in the test where you might, even if you're working ahead now, it may catch up to you, and that's the way it's supposed to work. But looking at these, we are continuing that percentage problem. So, if the information in the table were converted to a pie chart, then the central angle of the sector for lions would measure how many degrees? So, how did you guys set this one up, or how would you set this one up? It's going back to the idea that the entire circle is 360 degrees. I'll have to file that under my 345 as facts that you absolutely need to know. A circle is 360 degrees. We don't know what the angle is. That's what we're looking for. But we can set up an equivalent fraction where the angle is going to be representing the lions, and the lions were a 40 out of 200. And so the proportion of the survey is going to equal the proportion of the circle. And so we can set this up as a cross multiply, that the 40 times 360 will equal 200A, or in your calculator, 40 times 360 divided by the 200 will give us our angle that we are looking for. All right. And our last one in that section says, if the poll is indicative of how the 3,000 students at Center High School will actually vote, which of the following is the best estimate of the number of votes the Knights will receive? So, the Knights were 50 votes out of the 200 surveyed. You could, again, do this as a cross-multiply problem, or you could do it as find the percentage and then take that percentage of the total 3,000. I'm honestly not sure which one is faster. It really depends on how your brain sees it. For me, I would be breaking this down to, 50 out of 200, that's 25%. And so I would be taking 0.25 times the 3,000. But, again, you could have seen it as how many votes out of 3,000, and you could take 50 times 3,000 and divide by 200. Both of those are completely fine ways to get that answer. It's a personal preference which one you did. All right. Surface area. Not a difficult problem. It is more to do with how your brain is organizing it. My way of thinking about this actually would be to write on the drawing itself. I would be saying, okay, this front surface is 3 by 4. This is 12, and there are 2 of them for the front and the unseen back, so we have 2 12s plus this side is also 3 by 4. So again, this is 12, and there is this side and the unseen side, so there would be another 2 12s. And then the top is going to be 4 by 4 is 16, as well as the unseen bottom, so 2 16s. And that's where my brain would be calculating it and then running it through the calculator. There's lots of different ways to do this one, and it's a personal preference how you saw it. But you just have to remember, if you are finding the surface area of a box, a rectangular prism, there are the sides you see and there is the mirror image match that you cannot see. And so there are going to be two of this side, two of this side, two of this side. I try to think of them as left, right, top, bottom, front, back are the pairs of sides on that prism. All right. If we look at 17, this is very close to the end of Algebra 1. We are told that we have 2x squared minus 7x minus 15. But they also tell us that one of the binomials, one of the factors, is 2x and it's plus 3. And so we have a bit of an advantage here. You are not trying to factor this from scratch. You just need what the other number would be. And so it's a little bit of a guessing game. If we have 2x, what do we need to multiply to get 2x squared? Just the x. And if we have 3, what do we need to multiply by to get negative 15? Negative 5. And that's the missing factor. Don't overthink it too much. They gave us the one piece. You do not have to factor this from scratch. It's just filling in the blanks. All right. And for 18, a circular lamp base has a radius of 2.5 inches. When placed on a flat table, approximately how much area does the lamp base cover in square inches? So, it's just a circle problem. We are told that the radius is 2.5, and we are looking for the area. The two equations or two formulas for circles are going to be 2 pi r and pi r squared. Your brain will kind of file those, but occasionally they get mixed up in your head. Which one is going to be the area? Going to be squared. Area is measured in squared. And so the one with squared in the formula is the one that is giving you area. And after this, it's a matter of plugging it in. Because it says approximately how much area, you can use 3.14 for pi. You can use the pi button in your calculator. Both of those will get you close enough for the sake of the test. The answers won't be different enough to matter. Use whatever pi you're comfortable with. And so you would put into the calculator pi times 2.5 squared. All right. I've seen good things so far. Go ahead and next 5. All right, stop. A number of you are ahead as I looked over shoulders, so that is good. Again, this is where you would want to be on the test. You would want to be having a buffer. So, looking at 19, what is it asking for here? It's looking for the largest integer less than square root of 42. Don't overthink this too hard. If you run square root of 32, what do you get? It's going to be a decimal of some sort. What decimal do you get?
Like 547. Oh, 42, wait. 6.5.
Yeah, so what's the next smallest integer? You chop off that decimally stuff, the smallest integer is 6. So don't go too overboard on that. The idea is that if you have the square root of 42, it's going to be somewhere in between 6 and 7, because 42 is in between the perfect squares of 36 and 49. And so that concept shows up a couple different ways on the test. This one, it's very straightforward, and it's just the next smallest integer is 6. So she plans for number 20. We've got a big block of text. One of the skills for this one is to be able to pull out necessary information. We've got a room, and each one of the walls is 12 feet by 14 feet, which tells us it's a really tall ceiling. ACT isn't always real world applicable as much as they try to. Bedroom with 12-foot ceilings would actually make you feel uncomfortable. But how many walls are there going to be? So we're going to take our 12 times 14 to get the area of one wall, and then multiply it by 4 to get all 4 walls. From this, we are subtracting the window, which is 3 foot by 7 feet, or 21, and also subtracting the door. Oh, sorry, it was 3 foot by 4 foot was the window, but the door is 3 foot by 7. So we're subtracting 21 for the door and 12 for the window. That gives us our general area. What general area do we have? Hmm? 639. And so it says that each gallon of paint covers between 350 and 400 square feet. So if you take that 639 and you divide it by the smaller number of 350, what do we get? 1.8. 1.8, and we can't do partial gallons, so we're going to bump up to the next whole one of 2 gallons. And that would be your answer. All right. 21 is a relatively simple, simplifying monomial equation. We have a 3 and a 3 on the top and the bottom of our fraction. One is x to the 3rd, and the other is x to the 9th. So 3 divided by 3 cancels down to 1, which we don't have to worry about, and so that makes it disappear completely. But if we have x to the 3rd divided by x to the 9th, there are a couple different ways you could see this, a couple different ways you can do this, but the general rule that they are trying to build to is the idea that if you have division, you're subtracting the exponents, and so this becomes x to the 3 minus the lower number of 9, and we have x to the negative 6. So again, being comfortable with those monomial rules Sometimes they add into larger problems. In this case, it was just a general, can you do this thing? All right. So we have a squared plus 2a, a squared plus 2a equals 8. What is the setup for solving this? In order to solve quadratics, at the instant you have a variable squared and a plane variable, you need to set it equal to 0. We need to subtract 8 from both sides so that a squared plus 2a minus 8 equals 0. From here, there are a lot of different ways to solve this. It's just a personal preference on which one makes the most sense to you. If you like the graphing calculator, you could run that through the graphing calculator and quickly find those zeros. If you're comfortable with factoring, factoring is another fast way to do it. If you have the quadratic formula memorized, quadratic formula will always work. It's just a little bit too slow for what I would want. I call it overkill. It's too big a hammer. But I would probably be factoring because that's what I'm comfortable with. I'm looking for things that multiply to -8 but add up to +2. Because they're multiplying to a negative, I have both a positive and a negative number. And those that are 2 apart would be 4 and 2. So I have +4 and -2 for my factors. This would be a plus 4, a minus 2. But they asked for what are the solutions. And so the most common mistake people will make with this is they get to here and they've got +4 minus 2 and they want to say, okay, it's 4 and -2. But it's not. Solutions are about what makes this equal to 0. And so what makes this equal to 0, you can write it out if you need to, that a plus 4 equals 0. Subtract 4 from both sides, a equals -4. A minus 2 equals 0. A equals +2. And so that sign flip is one of the easiest mistakes to make, particularly when you're in that, I've got to go fast, I've got to get the answer, I need to answer, and your brain just takes it a step too far or too fast. And so, especially if you're using factoring, make sure you answer the question completely. Don't just say, oh, okay, I factored it, there's my numbers, go. And so, especially because you've done all of that work, make sure that you are putting your answer into the correct form. You are completing that question. If you use the graphing calculator with it, it would be a little bit easier to see, but it takes a little bit more time to type into the calculator. And so there's that trade-off, whichever way you are most comfortable with it. All right, last one. We had 23. From A to C, the first question I'm going to ask is the slope positive or negative? Positive. And so that right off the bat eliminates half of your answers. Anything you can do to process of eliminate down the number of possibilities from the multiple choice, that is always a good thing. Finally, from -4 to +4, that is our change in both the x direction and the y direction. It's the same for both. And so for me, I look from -4 to +4, it's gone over 8 and up 8. And 8/8 simplifies down to 1. You could have drawn on the drawing if you like slope from a graph. There are lots of different ways to tackle that, but whichever way you worked, that's our answer. All right, we're gonna take one more round of 5 and answers, and then we should be done for the day. So. stopped you just a little bit early so we have time to go over everything before it's time to pack up. So 24 is a classic linear equation problem. You have dealt with y equals mx plus b before. The most important thing to know is that that y-intercept is always a starting point. It's where you begin. It's the initial amount. It's a one-time fee. Anything that is only happening once, that is your y-intercept. Versus the slope, that is the thing that happens over and over again. It's the repeat charge. It's the, this is happening multiple times. And so, when we have variable costs, it's $1.50 per textbook, then this is 1.5 for every text. But it has the fixed costs is $900. It's going to cost $900 whether you print 1,000 textbooks or 2 of them. That's the cost to set up the situation. And so y equals, I use t for textbook, but we go back to x for traditional. That is your equation. And so the more confident you are with, this is a one-time thing, this is where I start, this is what I begin with, this only happens once per the instance, that is your y-intercept, versus anything that is per item, that is going to be your slope. All right. On 25, this is one that is either very easy or kind of ridiculously difficult. If you do not know the trick, you're going to have to go back to Pythagorean theorem to find this third side, and it's a little bit tedious. If you know the trick, this is a special right triangle where we have x square roots of 3. This is just 2 x's total. And so it's in your booklet on page 4 under a 30, 60, 90 triangle. But again, if you didn't know that, you'd have to do x squared plus x square roots of 3 equals hypotenuse, and you'd get x squared, and then you'd get plus 3x squared equals hypotenuse, 4x squared equals, no, that should be hypotenuse squared, and then you take the square root it, and you get 2x equals h. And so that's the background that you'd have to do if you don't recognize this special case. Again, the special case is a bit of a shortcut. If you don't know the shortcut, you'd have to use Pythagorean theorem. But now we can talk about the perimeter as x plus 2x plus x square roots of 3, or in other words, 3x plus x square roots of 3. And they told us that the perimeter was 15 plus 5 square roots of 3. Well, the 15 can be turned into 3 times 5. And so we have x, 5, x, 5, x equals 5. And so that's what's going on with that one. If you know the shortcut, not terrible at all. If you don't know the shortcut, it's a little bit algebra heavy. All right. 26. We have 4 square roots of 9 over y times the square root of 11 equals 4 square roots of 9 over 11. So what do you notice right away? These are the exact same. And so it's just distraction. All we're dealing with is that y times the square root of 11 equals 11. And in order to equal 11, you need to have something times itself. The square root of 11 times the square root of 11 is equal to 11. And so that's where that one is going. All right. I think we will go ahead and pack up. So, if you want to check any of your other answers, remember that this one does have the answers in the book for you at the very end. And so you can both see your answers and see the explanation of why on those answers. Have a good day.